All the guys can be quiet. Yeah, take that.
We have your thing.
We have 30. I don't know. One, two, three, four, five, six. Two missing. This is yours, Jason. Do you want him to record while judges questioning or individually? How we gonna do that?
Well, since the student they present each of the poster, and then we just asking questions and so on.
Tell him how to proceed.
Okay.
You can interview few minutes with him. You already podcast? Did you start podcast?
I did because it's 2 o'clock. I get started.
You can interview with them.
With want to do an on-camera interview? Maybe with this one. I mean,
Yeah. He's the competition chair. He's the advisory board chair. They can talk to you a little bit about the details.
okay, sure.
Let's do that.
Okay.
So you guys figured out what to do?
Morning session.
Everybody get closer. Let's get started. Everybody get closer. Wayne will do an introductory talk to each of us. Student groups, get closer, please. Wayne, please. Give us the details. What's coming up, please.
Okay. So we have the judges here. So where are the judges? Let's go. Okay, so good afternoon, everyone. Oh, one more time. Good afternoon. Thank you. So I'm Dr. Hong. I'm the guy who put the email with all the mails about this competition. Okay, we're supposed to have 8 teams, but look like some are lost, so we will wait for them. So the idea behind this would be we would like to stretch your creativity and see how manufacturing, how far manufacturing and design can go. This is our 5th year, so we're very excited about this program. And so we have 3 judges, 2 from academics and 1 from industry. Introduce yourself.
I'm Professor John Tester at Northern Arizona University. It's the smaller of the 3 universities in Arizona. I'm a professor of mechanics here, but I also have assistant engineering. I deal with manufacturing products. I'm Dr. Kong. I'm with Grand Valley State University in Grand Rapids, Michigan. I'm part of their product design and manufacturing faculty.
Here.
I'm Jared Bowe, SolidWorks. I'm responsible for the education at SolidWorks and working with all these universities across the world.
All right, then we have the advisories board. Dr. Mahid, can you say a few words?
Vahid Mutawalli, I'm Associate Dean for Research and Innovation at Tennessee Tech University. Very pleased to be here and be able to support this event.
Thank you very much. So we have the poster will be in order like this, right? So if you are ready, then we can start on this side and go to next and so on. So If you need just a few more minutes to set up your devices here, then please do so. We have power strips here and connect to that. Okay, so please go ahead and set up your device around here.
So you just start walking up and talking to them, or what?
Yeah, they will set up some things.
Or still waiting?
Do you want to go and interview each one, or they want to get closer?
I can't move. I'm wired. They do, is there a microphone?
But your two microphones here.
So hit the whole
It's no. That's not mine. But does it go through the sound here?
Yeah, there's a speaker there.
Okay, yeah. If you can do that, that'd be great. Because I can't leave. I have to stay wired. Yeah. So the microphones would be good.
I can call each group and do a little introduction today.
I mean, they gotta see you have to see the posters and everything, right?
Oh,
I mean, I
we can
thought you would be going around.
No,
and-
we have to be wired. We have to stay with the connection.
So we bring the poster up here.
We can do that. We can do
Okay,
that.
so bring the poster up here.
Do you want to start the first poster? We can bring it over. I don't mind.
Yeah.
Wow, the first question or about the
Up to the
Alright, so which way?
They do have
We need to be facing that one.
and so then we can go poster to poster in between these.
Could we give them
We have different board, we have
Okay, each team you will have 5 minutes to come by, introduce your work, and you will broadcast it live streaming. Then judges will question you. Who wants to be the first team? You come over to the stage and present with your poster and a marker.
This team does. They're already there.
Training and farmers is going. Let's get together. Get closer, please.
Excuse me, sir.
I do this all the time. You have to tell them, okay, go. Okay.
Go ahead and start presenting, please.
So go ahead and first, give your presentation relative to the And then go ahead and show us trying to destroy your poster.
We'll try to keep it in one piece.
Okay, get started, guys. Go ahead.
Okay, the camera is.
Be loud and start, please.
Use the microphone.
After all of you do your demos, we'll go by individually at your posters and ask you individual questions. Okay? We're mostly interested to see if it works or how it should work. Very good.
Go ahead. Get closer and start talking.
I can go. Okay. So our project is a charcoal press that we designed for a nonprofit organization that does work in Mikinduri, Kenya, which is a remote rural area in Meru, Kenya. And the problem that we were dealing with was that the people there were producing charcoal either from cutting trees or from very tedious processes using these pipes that you're probably familiar with. So they have these 2-inch pipes and they weld them together, they hammer them, they strike them, and they do charcoal piece by piece. So they say they have about a rate of 5 charcoal pieces per minute, and they're about 2 inches in diameter and 1 inch in thickness. And that's the rate they do it in every day, and they do it all day. And the problem is that they have very limited amount of accessibility to energy, and they use that for cooking, they use that for heat and all that kind of things. And thank you. So the current process is really tedious. So you can imagine it's really strenuous on their arms. It's highly manual. It's very inefficient. It's time consuming. They don't have a standard procedure, and it's low cost. They say it costs about $2 to make this device that they're currently using, but then it doesn't produce the amount of output that's worth the amount of effort that they put in it. So my group is going to be talking about the design process that we went through to come up with this idea.
We actually had multiple iterations of this design, mostly because it took a long time to figure out exactly what the client wanted. Our team here in North America is very hard to understand exactly the problem they were facing. Here we have, you can buy energy. Energy is not that expensive here. It's easily obtainable. There they can't afford fuel. And again, the trees is an environmental problem. So our first press design, we actually put what we call the rotary press. It's modeled very much after what 90% of industrial charcoal equipment is like, but it just isn't feasible to manufacture that. It's impossible. So we came up with what you see here is the cookie cutter design. So it allows you to press a large batch of charcoal all at one go. But you still get individual cuts. You don't get one large grip, so that's very hard for them to work with. So we had a couple of different iterations on that. One that we had them working on, that was a safety hazard, so it had to be changed. We had one that involved a car jack, and another one that we actually field tested in first that had a handle on it, but again, it's just too difficult for them to manufacture. It didn't work. So we came up with after that field test, we came up with our final design, which we call the lever press. It's what's shown right here. That Alex is going to demonstrate. And this is our prototype we got back in Canada, and it's we also have our drawing package, and then they built this exact same, almost exactly the same press in Canada as well. Okay, so the grid goes into the bottom of the press. We don't have any charcoal, which is too messy, and we don't here. So you put your uncompressed charcoal in the top, you put the plunger in on top. So this can do up to 16 liters of charcoal all in one go. And then the handle, you can pull up both the handle. and handle. This one is shorter, but make it longer as well, depending on how strong the user is and how much force you need to apply. So what else is,
And one of the most exciting part of this design for us is really that we were able to implement it in Kenya. So I was there last February, as you can see in this picture, and we were in coordination with the local polytechnic and the local forest conservation group. What we did is that we went to one of the forests that they're trying to conserve. We gathered a lot of forest waste, so a lot of dead banana trees, corn cobs and all that stuff. And then we were there and we demonstrated with a lot of farmers and locals on how to carbonize these agricultural waste and then turn them into charcoal powder and then use this press. And they were actually really excited. As you can see in this picture, they all wanted to take pictures with us because of how excited they were that this is going to help them preserve their forests while at the same time providing them income and also providing training for their polytechnic. As you can see in this picture, it's actually the local students. They're grade 7 or grade 8 students that welded the press over there in Kenya. So it was a really interesting experience, and they told us that they're going to start making charcoal as soon as they can, and we were able to manufacture one, and then 2 more are on their way. And as you can see here too, we did a bunch of testing in Canada. So these are all, we have a safety factor of 2 or 3 and more in a lot of our parts. So it's actually going to last long, and especially in Kenya, that they actually improvise a lot and things last longer than in here because we change our things pretty often. And then one interesting thing too is that when we came there, all the materials that we needed were available. They were able to provide some parts of it, and it only cost about $200 to make, but that was only because we had one to make. But if we had more of them to make, it's actually going to be a lot cheaper because of the division of the material costs, and the labor costs would be free because the polytechnic is using it to train their students, and then at the same time they're producing charcoal presses for their community to make income.
Good.
Thank
Tell
you.
you're excited about it. Now we'll go back to your poster once everyone else is done and ask you a few questions. Thank you. Thank you, everyone. Looks like this team wants to get up. By the way, I don't see them on the list. Did you? Yeah. Okay, so I'm going to call team number 9. They're called
So as we are transitioning
UPT.
to the next poster, let me just quickly explain something about the live stream. So this event is being live streamed in order to showcase what is happening at ASE as part of the National Week of Baking that was declared by the White House and launched on last Friday, June 12th. So if you're participating in this event, there's a chance that somebody in the US or around the world will see you as being, as this event is one that also being promoted through the White House portal. And so Tennessee Tech is very pleased to be sponsoring that live stream, and we are doing a lot to promote innovation and the makers movement, and hope that more of the universities will join in, and a lot that are doing this already, and we very pleased to see so many innovations being presented here. With that, I'll turn it back over to the poster presentation.
Good afternoon. My name is Stephen Gertzen.
I'm Joshua Sauber.
And we are from Eastern Mennonite University. Eastern Mennonite University is located in Harrisonburg, Virginia. It is a small liberal arts college, and we strive to maintain and create an environmentally sustainable community. We will be presenting on a solar-powered chicken coop, and Josh will now describe the background of the project.
Yeah, so EMU is known for trying to be very environmentally sustainable with all their efforts on campus. In 2010, they set up a solar array on top of the library on campus, and at the time, it was the largest solar array in Virginia. Since it was built, it has been estimated to have produced over 500,000 kilowatt hours of energy. It has saved 400 trees and estimated 300 barrels of oil in energy costs. So the purpose of the purpose of this project was to improve a chicken coop that's been on campus for a long time. That's been a model for a sustainable environment to raise livestock and produce eggs and food without using too many resources. And so currently we're able to provide water for the chicken coop through rainwater collection, and all the food that's given to the chickens is provided through leftover food from cafeterias and other eating places on campus. So the last thing that we needed to finalize in terms of sustainability was getting power to a heating unit and a light bulb inside of the chicken coop that provides light to emulate a longer day during the winter, and also to keep the chickens warm during those times. So we set out to create an easy and affordable energy solution in terms of solar panels.
To accomplish this goal, we determined that we would need 2 batteries to power both the lighting and the heating units. And to do that, we would need 4 solar panels. As you can see here, this is one of the solar panels we built already. This was necessary to power the battery, which would then be used to power the heating and lighting units. The panels were constructed of 4x6 solar cells. As you can see over there on the left-hand side, there's a picture of the solar cells being soldered together and then connected to a glass. It would be the cover for the panels. Then they would be supported with wood and rubber and then sealed with silicone to keep it waterproof during the storms. Here on the poster, you can see a model of what the array will look like once the panels are done and completed. This is a model of the chicken coop that they will be put on, and we have not determined yet the angle, but we determined that we would need a specific angle to maximize the energy efficiency depending on the season. And to go along with that, we did 2 analysis of the panels, one using Autodesk Rivet. We determined the power output based on the location and the time of year. So that was able to tell us how much power we would be able to produce. And this other result was the same idea, but it determined basically the power output based on the actual solar panels and solar cells. We found that we would be able to produce 338 kilowatt hours annually. This was more than enough power to power both the heating and the lighting unit for the winter months. The wiring diagram here on the bottom left shows how we are going to set up the panels once they're completed. We will have 4 panels with 2 panels in series and then 2 pairs in parallel. And then that would be connected to a solar charge controller, which is used for regulating the charge to the battery so as not to overcharge the battery. We also had to include a small diode in there so the battery would not try and send charge back into the solar panels and damage them. And then once we got the battery charged, we needed an inverter to take the charge from DC to AC power so we could run 2 110 volt amp outlets.
Okay.
So calculating the materials, we ended up being able to produce this with a bill of less than $600. Took a lot of time planning this out, doing some research, assigning people to different teams, and we ended up figuring out that we would be able to sustain this year-round and provide a completely independent and renewable energy chicken coop that would be able to provide eggs for the cafeterias on campus, and eventually if that would be the case. And we figured this would be very easy to replicate in smaller areas and even on larger scale. We wanted to thank DSW because they helped us to fund this project.
Let's give them a hand.
Thank you. We have about 5 to 7 minutes each. You know, we need to see it perfect. You know, the demo's there, see the demo, and move it. There's a last. All right.
Can we get this outside pitch?
So that way, yeah, there's
Sprays water. Yeah.
Hello, we're from Washington State University and BSE, which is located in Everett, 30 minutes or 40 minutes north from here. I'm Alex, this is John, Andrew, Mark, and Vikram. And our project focuses on harvesting unused energy from water.
So our design idea centered around the fact that in Seattle it rains quite a bit. Last year we got 48.5 inches of rain. So you can imagine that on the top of every building is about 4 feet of water worth of potential energy that's just being wasted. It's not being used for anything, it just goes, drains to groundwater into the sewers. So our goal was to create a generator that could go at the bottom of a downspout that would allow us to harvest at least a portion of that energy to be used.
So we had 2 designs going into this. Our first design was a water turbine, which here. Basically what it consists of is a machine shaft extension to a DC motor for magnets for the generator. This is just kind of way we 3D printed this. That's just a quick model. This required several iterations trying to get something to work for what our system requires. So we don't have that leverage, that height to really test on an actual house. So we did rapid prototype for the look of it. And the way we looked at it was that this was not good unless you had a lot of mass flow, a lot of volumetric flow rate. So we opted with a water wheel design, shown here, and that is hooked up there. And that really allows the water to hook up on every single cup and spin it quicker. And if you want to talk about the display.
Yeah, so the display system we have set up here, it's got just the 2 tanks. It'll take water from the bottom up to the top. We've gotten our Arduino system that will fill it up to a certain level and cut off. And then we drain out the drain, down the downspout, into the water wheel, and it drains back into the tank. There is just a little bit of a splash zone because we wanted to make it so you could see what was going on. So water kind of splashes around. If we did like a production one, we would have casing around this so that it didn't just spray water everywhere. And then as this spins, the motor will power, or will go into another Arduino that reads the voltage and the lights light up based on how much power is being made. It'll go into green, or red is approaching the maximum output for the motor. We're probably not going to hit red, we'll probably stick in green. And then I think that's time to run it.
Yeah. Make sure it's ready.
All right, here we go. So you can see it is spinning. When we were testing it earlier, we were getting it up into green. It's not now. The wheel just isn't spinning fast enough to get it up into the green, but when we were testing it before, we were able to. As you can see, it is spinning. You are able to get some, at least the falling water into mechanical motion that would go out into the motor and ideally create some power.
Right, so being local or in Everett, we were looking at both home application as well as commercial usage. And one model that we really looked at, because it's right down the road from us, it's just happens to be the world's largest building. There's 398,000 square meters of floor space. So we figured out that with the given height, based on the volume and that floor space, annually, this thing could power, if this was on every downspout in there, it would power 35 homes for a whole month apiece, based on average energy usage in the Seattle area. And that's only 25% efficiency for a product. So research and development could go into this to make it a lot better. It's just a prototyping stage, but 100% it'd be about 152 homes for full months. That gives them. Yeah, just coming from something that we don't utilize at all in this area, which is pretty good. And manufacturing, if we wanted to mass produce these, if it was used with another bit up top to really accumulate the flow, we could make it so that the volumetric flaring through this would work for this design. We have enough space here so that water sort of goes through. Well, it does go through. Really nice for high flow applications. And this can be injection mold. For this, we can do either sheet mold forming or injection molding if we wanted to mass produce it. Exactly. And you want to conclude?
So that's pretty much it. As unfortunately you weren't able to see, but as you can imagine, we're able to harvest at least a little bit of electricity from the falling water. If we were able to optimize it, get the design better so that lower flow can power more, you could use it for other applications. You could put it basically anywhere that water is falling. You could be drawing at least a little bit of power from, getting more and more just clean energy from water that we're not using otherwise.
Let's give them a hand.
Thank you.
While the next group set up, let me talk about the competition a little bit again. Design and manufacturing competition is one of the key events of the manufacturing division every year. In line with the week of making, we try to make the event a national or international event. We have a live broadcasting going on and sponsored by Tennessee Tech University. We have design and manufacturing competition today, and tomorrow we have a make-it session. Both will be live stream, and anybody can come over and join us. We already have 3 or 4 student groups presented their work. Now we have another group. They just done their setup. We'll just go ahead and give them a chance to present their work.
All right, hey, I'm Josh Carroll, and this is Malcolm Stokes. We're with Tennessee Tech University. What we wanted to do with this project was what we're doing at Cookeville, Tennessee, in the manufacturing engineering department, is a lot of our senior design projects, we're having a major emphasis on environmental aspects, whether if it's with solar panels, biodiesel, anything of that sort. So what we wanted to do, we wanted to take that and put it at a small scale and give you at least a smaller demonstration. It's a simple demonstration, but a very detailed demonstration nonetheless of what we're doing. So what this is it's a solar tracking panel. It's basically a device that captures the highest efficiency of sunlight for the solar panel. So basically the concept behind it is that there's no PLC, there's all it is uses the basic concept of the Wheatstone bridge. So with that, it as the light is at a different position, it essentially adds voltage to the right side of this solar panel. So with that, it'll turn it until it reaches a point where there's 0 volts, and then it'll stop. So with that, if the sunlight, for example, were in this position, it will turn until it reaches the midpoint at this solar tracking panel, and then at that point, you're getting the maximum efficiency of the solar panel. So basically, with this device, at least a small-scale device, it allows for things such as even something as simple as iPhones charging. It can reduce the amount of batteries being used. There's a lot of benefits that can provide some a portable option for powering your devices. So with that at Tennessee Tech, for this being a small scale, a lot of things that we're doing with this technology is we're taking this and putting it on many different devices. For example, we have a go-kart right now a golf cart that actually has a solar panel on it that is fully dependent on the solar panel. And with that, possibly in the future, we're actually going to use this technology so that if you're parked in a park spot or just parked at the house, it can get the maximum energy inside for the golf cart. So with that, you can explain a bit more about what we're doing with this.
Well, yeah, we have the golf cart, and it's had a manual solar tracker on it before. You kind of park it and you can move it, but it really kind of finds to be a little bit of a hassle. So we've worked more on the next big project is going to be getting that automated solar tracker on it. And we're going to see how that works. That's going to be the big design project this coming up semester. We also have a water heater, solar powered. Right now, it pretty much works as it'll collect sunlight and use that sunlight to heat water as it falls down through pipes on top of houses. And then our next big project, other than the golf cart, is going to be using solar energy to produce biodiesel. That's one thing we're working on this next year.
So now we talked about the reasoning behind this. We'll go ahead and demonstrate it. The solar panel itself, if you want to, the solar panel itself is a pretty small scale solar panel. So it doesn't pump out much voltage. So, but as you see with the light, it turns with the light, and it can go at some serious angles if you want. It can go all the way down. You can do almost horizontal, and it'll still follow it. As of right now, we're getting a 0.1 amps, and then 0.01 watts or watts, and we're getting not many volts, but just enough. So as you can see, this is the basic principle. You see, we're getting enough voltage now to be able to charge a fan, and with this, it can be a fan, it can be your, like I said, your iPhone, anything of that sort. So that's our project.
Next school who wants Texas A&M? Let's have one of the Texas A&M groups. Please.
Hey, the link I tweeted, can you keep doing it so people know because it's the link to this. Yes. Thank you. And I think I'll find one tomorrow. This is a lot easier because they're moving a lot. It's just this.
There's no byline or nothing
No.
identifying what it is.
There's a title and a description, but not this part.
Looking they might have like a frame that says ASE event or something, and then
It'll say student design manufacturing competition.
nothing. It's nowhere that it could be, let's say.
I'll put Tennessee Tech in the next one.
And the next one is you mean tomorrow?
Yes.
Tomorrow and then
Hello everyone. Good afternoon, honorable judges, fellow participants, organizers, and sponsors. Thank you for making this event to happen. I'm Cheryl Lowe from Texas A&M University, representing my team called Team Mean Green. Unfortunately, my group mates, Jen, Elwin, and Adam cannot make it here today, so I'll be presenting on their behalf. The topic of our study is called F3, which stands for Fuel from Food. it is the sustainable energy source aims to tackle a global environmental issue, more specifically, food waste. So what is food waste? As you can see, this is a cute example of food waste. Or in a more generic term, you see when you go to restaurants, you have left uneaten food, or when you cook at home, those disposed food, or even when you eat a banana, the banana peel is also considered as a food waste. So food waste occurs in almost every part of our lives. And where does all these food waste go to? Usually, this food waste will go to landfills, and these you see piles of food waste, and here it'll be rotten, and it attracts flies, and it causes health issues to us, which is an environmental problems. So when my team looked into this, we thought, how do we eliminate this problem and perhaps look at the existing solutions or even harness the potential green energy from food waste? So we look into a study, and it says that just from food waste itself, there's about 2,000 trillion BTUs of potential green energy. And can you take a guess how much barrel of oil this energy is equivalent to? Take a guess? No?
200 billion.
100 billion? Oh, that's really big.
20 billion.
Well, what we found is about 350 million barrels of oil, which is a whole lot of oil, right? So my team and I thought, wow, this is a lot of energy. Why don't we make a F3 concept, which is really fuel from wasted food? So how do we produce this food fuel rings? This is how our food rings looks like, by the way. I'll explain more later. So how do we create these rings? It follows 6 simple steps. First, we collect the food waste, and then we sort them. We grind them if it's too big, and then we mix the food waste. And then we leave it to sun dry for about 2 days. And then we compact them with our compactor design. And then we sanitize them, pack them to make sure there's no health issue. And then there you go. You can leave it for burning at any time, anywhere you want. So it's a process of converting food waste into energy, thermal energy. So how much does this food fuel rings how much thermal energy can it produce? So it really depends on the constituents of your food. So say in your kitchen waste has more oil or dairy product, it will have this much more energy to burn. And say if it has rice, like starch, then it has lesser energy to burn. So after leaving the food to sun-dry, we came up with our compactor design. This is the cross-sectional view of the compactor design, and that's our completed food ring. I shall demonstrate to you on how our compactor works. This is this envelope version, by the way. I'll show you how it, and when it assembles, and when it compacts the food waste. We treat this as food waste, so we put it inside. This can be done at home or even on an industrial level. This is a basic concept. This is the main fuel ring. And this is the tool, we push it down. We push all the way down until we reach to this level, which means our fuel ring is compacted. And then we can remove the item, and there you go. There is our F3 ring. It's broken now, but yeah, that's how it works. So from our compacted fuel ring, we wanted to optimize our fuel ring. We looked into, is there like a food ratio that produces a much better fuel ring? So we made our experiments we made different ratios, and this have a higher leftover mass, which means it can be for slower burn, what we call slower burn, and this is for faster burning. The difference between these two burning ratios is for Like this, if it's for kitchen use, you want to just or go to a campsite, or if in the winter for keeping warm, you use a solar burn. And this for a higher energy burn, then you will use for this higher energy burn. Yes. Then from here, this is the image of a stronger burn, and I can show you 2 videos of how a slow and a fast burning works. I actually made a PowerPoint, but unfortunately it cannot be played. So I
think we
just
can wait those for judges. We have any?
the poster.
Yeah, we already saw a demo, so.
Oh, the demo of the burning. The burning.
Let's go ahead and see that when we come around the posters.
Okay. And so after with the burning, then we wanted to compare the different fuel sources, like for natural gas, petroleum, coal, and biomass. So this is where our food waste stand, which is actually better than biomass, and it's a not bad alternative to charcoal. From here, we also looked at how much per person waste a year. It's about 194 kilograms of food waste per person in the US alone. That's about 4 times my weight. So from this food waste, we refer to our graph to see how much energy it can generate. So 194 is then estimated about 970 kilowatt hour. And from here, from the economic standpoint, we looked at how much cost saving it can save. So 970 kilowatt hour times the electric cost by state times the population in each state. In the state of Washington alone, we can save up to $1 billion. And if you look at, imagine United States, everyone use food waste, it would save up to $29 billion. So it is not only is a cost-efficient fuel, it's also energy efficient, and it also eliminates health problems that it causes. With that, I end my presentation. Thank you.
Thank you. Next group, please come back.
Injury. Whoops.
Hello, everybody. My name is Zhao. I'm representing a team of 3 high school kids. Emily, Michael, and Julian. Our project is a robot. The robot has 3 components. The first component of our robot is the controller. The controller is an Android device. Any Android device will work. The second part of our robot is the physically robot, this part. And the brain of our robot is EV3 controller from Lego. Everything except this came from Lego. The robot, as you can see, has 3 motors. 2 motors control the left and right wheels, and the third motor control the eye of our robot, eye and the ear of the robot, which can rotate. That's the third rotor. The robot also has 3 sensors. The first sensor is a color sensor. can read the color of the ground, different carpet or different floor. The second sensor is the ultrasound sensor, which can measure the distance of the object right in front of the robot. The third sensor is an accelerometer, which can measure the angle of directions, which way the robot is moving forward. That's the hardware part of a robot. The software part of the robot is an Android application we developed. The application looks like what we have on my Android device. It has a couple of buttons and also has an image because the robot has a camera. The camera is connected to this Android device through internet protocol. So basically, everybody with an internet connection can receive the video and audio, also your audio. What we have here is the robot can be controlled two ways, by push buttons. For example, right now, if I say moving forward, backwards, that's turn, right turn. So that will be the control. There is a slider for control the speed. So I want to move forward faster. So that's a faster forward. The part we worked on also has a voice control. Basically, there is a voice. I say forward. Forward. Basically, if I so it recognizes my voice. The voice is from Google. So basically, voice recognition not limited to English. Any language will work as long as you speak native tongue. There's also a camera on top of it. The camera can rotate clockwise. It's too fast. I can slow it down. So it will rotate clockwise, counterclockwise, or clockwise, either way. And the camera image can be displayed also on the app on the bottom part. So basically, you can see it's the camera is a web server. So basically, if at home, that's the web address of my camera. But here, I don't have control of IP address of my camera. So basically, this part cannot be demoed. But anyway, that's the control from my Android to the robot is through Bluetooth. Camera is through Wi-Fi IP. Basically, the application, what we can do is do video and audio surveillance. As far as it's up to 40 yards, 30, 40 yards, because that's the maximum range with Bluetooth. So that's the maximum range. So basically, I will control my robot upstairs, control the robot in the basement with video. The video part is anywhere in the world can be watched because it's IP internet. So this part hasn't been finished. Remote sensing. Remote sensing can be done through the Bluetooth direct command. Bluetooth direct command basically talk to EV3, Android talk to EV3, and read the sensors, and transfer back to the Android display. That part hasn't finished. And the future work includes, instead of Bluetooth, remote control, use the Wi-Fi. So instead of 20, 30 yards, you can have 20,000 kilometers away, anywhere in the world. So that's our project.
Thank you.
Thank you.
We have more schools coming up. Well, the next group setting up their poster in the project Maka. Let me give you a little debriefing at the beginning. Design and manufacturing competition is one of the key events of the manufacturing division every year. This year, the topic is environmental enhancement. The universities are presenting their posters and project mock-ups. We also have a live streaming of the event funded, supported by Tennessee Tech University. Through the internet, many other universities, schools, or whoever have an access to internet can see what we have been doing at this time. We have few more schools that are not done yet. Initially, 8 schools signed up. I think 5 or 6 already presented. We have few more coming up. After getting the presentations, judge will question mortar teams, and then we'll have award ceremony coming up. We are not going. First presentations and judging and the award program. We have more to go.
Hello everyone. I hope everyone is all well. We are a team from IUPUI, which is Indiana University, Purdue University, Indianapolis, and we are from Indiana. Our project is about an agriculture drone where we help the farmers there on planting the seeds or maybe fertilizing, and because we know that Indiana main agricultural plantation is corn, potato, and tomatoes. So with having this low-cost drone, it will help the farmers to cut costs, and also it is environmental friendly. The total cost of this drone is less than $300, and this drone consists of camera and seed storage box. But for now, the seed storage box we don't include it for now. My friend will explain about the features of our project.
Okay, ladies and gentlemen, now let us invite my hero again. So actually, we call this one as a challenger. The reason is, as my partner said, so in Indianapolis, farmers feel hard to separate the seeds to the ground, and then the damage given by the pigs. So they spend so much time on doing this. So we noticed this problem. So we were trying to get the drone to become an agricultural drone, which means because the drones existed now, it's only fly and take a picture by yourself. But if we use it to the agricultural area, then we can make it spread the seeds, sorry. And now I will introduce some technical specs. For the first phase, we plan to reduce because it's based on low cost. So the first thing we did is the 3D printer. So we print all the frames by ourselves, and this is the frame. So this will make the cost very reduced. And then here you can see the electric speed controller. And this is why you can control the speed. And then, yeah, and then we choose the low cost from products from China, and then make the total cost at $300. I know $300 doesn't mean anything if we don't have the concept of the marketing. So the product this now is about 500 to 1,000. So we lost half of them. And then the second phase, we focus on the programming. So if we want this one to realize the function, you need to move it up and then go to a certain place, and then go down and spread the seed, and then cover the soil, and then move to another place. This is what we are trying to do. So we program all the process, and then test it using a Linux language. And then the third phase of our design is to put the program into this drone. Unfortunately, because our communication difference, so in the first step, we're trying to make the cost lower. So we choose the low quality sensor, controller, low quality controller, which means our language is not really capable to it. So some of its functions lose, but it's still workable. It still can move, but we lose the seat open door. Seat open door. And then for the job, we will focus on the fertilizing, which means if you have the water pump here, and then you can just open it and then separate the water, and then it was a lot of works for the farmer. And then the second one is, notice we have a cam here. So once you take pictures for the whole area, the whole view, and then you will get feedback to the cam itself, so that the next time it goes to that place, you will detect the color of the grass. Like, let's say, for example, if it is yellow, then the next time it passes here, it will get more water into this area. It's a feedback system, and that's what we are doing. Thank you.
Okay, in the future we will integrate the drone with the GPS system so that we know where it is that needs some fertilizer or water. I think that's all from us.
Thank you.
While we have the last group setting up, let me go ahead and read you the sponsors of the program. American Society of Engineering Education and 10 divisions is sponsoring the event. Number 1. Number 2, Texas A&M University College Station, College of Engineering at Tennessee Tech University, Grand Valley State University, Momentum Press, Calculated Industries, CRC Press, Industries Press, PCS Engineering, and SolidWorks. Now, we still have the presentations. After the presentations, we have a little more judging and award program. Each student has an award. Please stay till the end of the program.
Hello everyone, it's me again. I'll be presenting on my friends' behalf, Huang, Heidel, and Brenda. The topic of their study is called Process Selection for Energy Efficiency. So in an airplane or for the automobile industry, we need precise holes. We need to fabricate precise and quality holes to make for the close fit of joining parts, to make sure that it's reliable in a dynamic or harsh environment. So the ideal process to making these holes would be to consume the least energy and at the same time the best quality product. So we assume we're going to fabricate an 8mm hole with a thickness of 4.86 millimeter plate, and we use comparison of aluminum and steel for the aircraft and automobile industry. And from there, we wanted to make sure it has the best quality. We wanted to have a hole with a smooth surface finish, uniform dimension, low residual stress and grain distortion, and also minimal surface defects. From here, we know our objective and we selected 3 manufacturing processes. The first process is the mechanical punching. So what a mechanical punching does is just like punching your paper. So it's shear vertically and pushes down the material. That's how it removes the material. This is a fast process. However, as you can see, it will create crack after you punch. So in this sense, it is not a very quality hole that it produces. And because of this, we would need extra steps, the secondary process, to correct the hole dimension. So there's, to correct the hole dimension. For the second process, we selected the EDM, which stands for electrical discharge machining. So how the EDM works, it's from an electrode, it runs the electricity. So the electrode creates sparks and it's hot, so it melts the material, and so it melts the material, and so it removes the material. For the third process, that will be the ECM. ECM stands for electrochemical machining. This is somewhat similar to EDM, but it actually uses the chemical process. It uses chemicals. From the chemical, it removes ions, and that's how it removes the material on the workpiece. So those are the three processes that we chose, and we will look into the microstructure in this part and in this part as the results. So as you can see here, these are the three processes. The punch, firstly the punch. After punching, this is the wall of the hole. It's not uniform, and in the end it creates crack. So with this, we have to correct it. We have to correct it by deburring, and then after that we have to hold. After holding, we need to anneal because there's some plastic deformation with the grain distortion. And so that is extra energy that is consumed. For the second process, in the EDM, similarly, this is the hole of the wall, and it's not very uniform because the material gets hot, so it melts and solidifies again. So it creates a recast layer. With the recast layer, there's cracks and bubbles, if you can see more closely. So because of this, we will need to hold the material, and that is an extra step again. For the ECM instead, you can see from the hole of the wall all the way and up outside of the grain. The grain is consistent. The grain was not distorted at all. So there's no additional processes needed. So from these three processes, we calculated the total energy consumed for each processes and each material. For the punching, the total energy would be energy of punching plus energy of deburring, energy of annealing, and energy for annealing, total energy for punching, total energy for holding, deburring, and annealing. For EDM, the total energy would be the electrical energy and the holding energy. And for ECM, it would be the only electrical energy. And so you see the trend. This requires the most energy, and ECM requires the least energy. And thus, it also creates the best quality. As a conclusion, ECM creates the best quality whole. And we are also suggesting to have a hybrid EDM-ECM process. So to do EDM as a rough machining, and then we surface finish with ECM to create the fastest and also best quality hole. And that's the end of our presentation.
Thank you. Let's give her a hand. Next is, we have three judges. Judges will question the individual posters in the projects. Might take 10 minutes, 20 minutes, I don't know how much.
they have the most information they need, but they might need few more. While they doing their final judging, I already talked to student groups, and students groups will come one by one, convey their individual reflections for the projects they have done. I'd like to start with the Washington State University, please.
Let's go ahead and left, right.
Hello, my name is Alexander, and the experience I've gotten from this project is how to work with a 3D printer, especially a powder-based 3D printer. I've never used one before, and we had to print many parts on it in multiple iterations. So I've learned how to open the 3D printer, how to take the parts out of the printer, and how to cure them and how to assemble them together. Thank you.
Thank you.
I'm John. The biggest thing I got out of this is working with a group on kind of an open-ended project under a time constraint, something I haven't done before, something that I think is going to be very valuable for me moving forward.
Thank you.
One second. Let's do this behind you guys. Just wait.
Mark WSU. On this project, I learned a lot about rapid prototyping and limitations of 3D printing.
I'm Andrew, and I learned a lot about time management and how to start from an open-ended project description and sort of formulate a problem and then introduce something.
Hi, my name is Victor, and I'm from WSU. And I learned to work with a team and time management too.
Thank you.
Thank you. Washington State University both gave us very short and sweet statements. Let's hear some more from yes, Virginia folks.
I'm Josh from Eastern Mennonite. I'd say for this project, I really learned a lot about how flexible it can be to produce something that is really efficient and cheap. It didn't take very long to build our first solar panel, only several days. But the resources were actually much cheaper, and it's really learning experience.
My name is Steph Gertson. A few things that I learned from this project were that solar panels can be built very simply, as my classmate already said, but I also learned some key organization skills and some key just leadership skills along the way on how to organize a project. And we struggled with that at times, but we maintained our composure and we were able to finish the project and come here to present with a poster and a project that was completed.
Esther, come.
Actually, the background of this group came from Hartford University. We are, as they said, is a pro-art university. I really appreciate the work the students put in, and also the support from our university levels and from the administration to the department, and all the support from all over our university. Again, to have this group of students to work with. It has been a great pleasure for me, and also our projects we work on are all real world projects, and they are like the greenhouse we build. They are used to grow vegetables, and then this solar panel project is going to be used for our chicken cooks, so kind of environmental friendly, and also. We got our funding also from these resources, which are all sustainability related. Like one is this one is from funded by Engineering for Sustainable World, and another the previous project is funded by Earth Speakers. So all sustainability related. So again, I'll be grateful for all those support. I guess that's it.
Hello, my name is Xiaomeng Bi. I'm a faculty member at the new program, Washington State University in Everett. Many of our students are first generation college. So I'm very proud of our students, in addition to these 5 students. We started with very limited time budget. So they are creative in the idea, and they use the readily available, very cheap materials, a fish tank from the store, wood pieces, and so on, and putting in time and to design and work hard. Many of these projects, the parts were done over weekend. That is, they have a lot of homework, other assignments, so on during weekend, Saturday, Sunday. They come together, work together as a team, and get this done. In addition to this design to harness energy from the gutter rain, they also start to play with the control of the water level and greenhouse way beyond the level they are supposed to get. That is, they are junior students that utilize learning some electronics with this ideas. I'm very, very proud of all my students. Thank you.
What I learned from this project is that I learned more in depth of the manufacturing processes, and I also learned of presenting skills, which I haven't done much in school. Also, what I enjoy a whole lot is working with my team advisor and my teammates. When we debated a whole lot and questioned each other's methods on how we research and if our methods are right. So that was actually really fun process.
Thank you.
My name is Michael Stokes. I really enjoyed the designing aspect of this project. It was time consuming a lot, but learning to manage time a lot with work every day and then getting off work and coming straight to school, working on this project all the time. It was really tough, but it was nice to get used to. Being a MET, manufacturing engineering, it's solar panels and environmental stuff isn't something we focus on all the time, but it was really nice to get a little hands-on and get used to it and maybe take that out in the real world and incorporate that into what we do.
Thanks, Mike.
A big part of this project was dealing with time constraints. I mean, between basically the entire process was done after 6 to however late we needed to go. Between that and then working on it, even the study abroad trip to Turkey, working on it during that time. So during all that, I was able to learn a whole lot, learning time management, learning, as he said about our department not having much electronics. It was the first time dealing in depth with electronics, so we were able to learn a whole lot about that part. So, and then it's been a huge learning experience. It's something that's something I can take and build on in the future. Thank you.
Just one more thing I want to say about our project. Our robot is from Lego. It's simple enough for kindergartens, and it's sophisticated enough for college students. So the software was developed by Apps Inventor from MIT. It's an application development tool for Android. Again, it's simple enough for kindergartens to start, and it's also very complicated for research or college students. But, I just hope more people will use those tools.
Thank you.
Hello, my name is Wei Chen. This project made me use my theoretical knowledge into the reality. So that made me very tough because theoretical is something that, but reality is something we can actually use in your life. So that's what I learned from this event.
Thank you.
Hello, my name is Yuren Chen from UPI, and in
this project, the most valuable thing I learned is probably the experience working in group because each of us, we specialize in different majors, so it's kind of hard to work together. But it's very fun because this is actually a very interesting topic. So while working in a group, we communicate a lot and we learn a lot from each other. So thank you very much.
Thank you.
Hi, I'm Fatin Baharuddin and I'm from IUPUI. This is my first time flying a drone and also into 3D printing, and it's a great experience for me because I actually had the chance to stay with the machines. Overall, this trip, this is a very great experience. Thank you.
Thank you.
No, we have. Michael.
Hi, my name is Michael Gallo, and I was the mentor for this project. It was very rewardable. Sometimes you think that the students learn, and sometimes I think we both kind of learn together. And sometimes it's a competition in the team itself who's learning more. It's an exciting time. This is the second time I've been to the ASWE conference. It's the first time participating in the design conference, part of it, and it's fun. It's also important that we focus in on, for engineering purposes, what we can do for the environment. And there seems like there's a lot of information here. There are all great topics, and hopefully when these students go out in the real world, they'll actually be able to work on some of these real projects. So, the reality. Thank you.
Thank you, Michael.
Hello. So for our project, it was actually a really interesting experience for me as an engineer because it's almost like developing us as a holistic professional and not just being able to design something or create something mechanical. The project actually developed us as like giving us a perspective that as an engineer, we're not only concerned about the small part that we're designing right now, but actually everything that we do is part of a bigger picture, it's part of a bigger system. So this project helped us to appreciate that systems thinking that and global perspective that we wouldn't have understood otherwise, that engineering really is as much of a social problem as it is a technical problem. And I think that was one of the major learnings for me. And also during this project, I got to practice a lot of different skills that I wouldn't have practiced otherwise. We got 3D printing, we got CAD drawing, and then we also did project management, and like a lot of different things. And yeah, it was great. And then I also got to go to Kenya, where I got to interact with the clients, and that I wouldn't have done if I was in engineering. So.
One of the biggest things I learned was about design iterations, going through multiple iterations of design, how do you improve every iteration, going to the client, see what the client had to say about it, and then we started doing field testing in Kenya, and then making more iterations, and just even just some of the assumptions that we had made originally, like we assumed that they would want small, flat charcoal briquettes like we use for our barbecues here in North America. But it proved not to be the case. They prefer larger bricks so they can have to cook home meal with. And it was just about learning some of these things that we had made assumptions about, but then they didn't turn out to be what the client wanted. Just learning that and learning to see things from their perspective and what they really needed to, they wanted from their fuel source and what they really need to get the job done, not just what we thought was best or what was cool, or what suited us. Thank you.
My name is Alex Campbell. I'm at the University of Prince Edward Island. One thing I really think I learned more than a traditional mechanical or discipline background at UPI, we really focus on design-based engineering. and focusing on creating real products for clients around the world. So I think this really helps develop managing and professionalism skills. Regularly, we communicate in meetings with clients and users, multidisciplinary teams. So it really helps develop our soft skills rather than just technical. It's really great.
All right, I'm Spencer Montgomery with the University of Prince Edward Island. I was part of the charcoal press for Kenyan farmers along with Kayla, Alex, and Daniel. This project was really rewarding. I myself was with the project a year before the other three came on board. Our class had tried to come up with a solution for this charcoal press issue to no avail. Luckily, I got a second crack at it, and we ended up coming up with a successful design, as you can see from our presentation. What was really rewarding about this experience was that it was such an actual hands-on project versus a figurative problem that you didn't actually get to follow through and see it implemented in, say, a place like Kenya. We were actually able to manufacture it, obviously, and work with the people of Kenya to implement it. Yeah, it was really rewarding.
Thank you, Spencer.
Thanks.
Hi, my name is Olivia Osgood. I am a professor at UPEI, University of Prince Edward Island in Eastern Canada. This is an exciting opportunity for the students to build and come up with different ideas that can actually make an impact in the world. It's really exciting to be able to show the social aspects of engineering and the really big impact that we can make in a positive way, and additionally in a sustainable way, so a way that the students can actually make long-term changes to help the environment and to help the world, as opposed to potentially negative ones. Additionally, it's nice to see the students getting really engaged and excited about their classwork outside of class, and really engaging in the project so that they can commit to it, and they spend many extra hours and work extra hard to make sure, because they're working for a client, to try to do something good for the client. So this is an excellent opportunity for students to make a positive impact, enhance their reflection skills, enhance their communication and professionalism skills, and the ability to travel for us thousands of miles to be able to show their design to someone else and see that other people care about their ideas, validating what they're doing. So this is really exciting, and I'm pleased to be a part of it.
Lane, you want to be the next?
I am Wayne Hong from Texas A&M, and the chairperson of this wonderful competition. This is our 5th year that we were doing this in a row, and very excited to have many teams from different parts of the country, from community college to high school to university participating in this. And this year especially, we're so thankful to have Tennessee Tech and generously giving the award give to the participating team, and also supporting the live video this event. And so after this, like you see at the back, then the judges are working and questioning the students individually, and the students seem to be very happy. They mix with different teams, and they talking, and they learn from each other as well. So that's another achievement that we have. We have students not only going here to compete, but to learn from each other and socialize, and so that wonderful event with thanks ASE and SME and who else? We have a lot of recent deadlines, calculating industry momentum class, and some CRC class, helping to make this exciting event. And we also thank you, ASEs, for generously sponsoring this event. So let me pass the microphone to back to Ismail.
Thank you. Wayne is the one doing the hard work for all this program, almost a year. Special thanks to we have some people sitting with the audience audio. I'm going to have some of our audiences from Connecticut in Florida. They are the NSF's Advanced Technology Center directors, and they have been doing so many funded projects years and years, and they've been quite watching the program. Let's go ahead and hear what they're going to say.
Thank you, Ismail. This is just a terrific competition. It's always great to see students that are involved in projects that are sponsored by ASWE. So when they come to situations and to addressing, power challenges, this is how we're going to change the world. We're going to address drought that's, issues throughout underdeveloped countries and really make a difference. So I just think it's so exciting to see this next generation, taking that next step and really getting engaged. I've talked to some of the students, they're all really excited about being here and the potential to be recognized. So I think every one of them is a winner in their own right. So I want to congratulate also the manufacturing division for supporting this, because this is just wonderful. It's a win-win for all of us.
Hey, so again, this is awesome. The whole thing that we're doing here with engineering education is all about the students, and we're all here learning how to teach them better so they can be better participants in the future. And so they're doing an awesome job. I often get a chance to judge these guys, and it's incredible trying to pick out the best winner. They're so excited about what they're learning and what they're doing and what they're going to be able to do. And certainly they learn so much by coming here and interacting with professionals already in the field. This is just an awesome opportunity for them. And Karen's right, they are all winners just for getting here. But someone's going to get a prize, and we'll congratulate them especially at the end. That's good.
Okay, the program is continuing. We are almost getting closer to the end. We have gifts to each student to be presented. We have grant awards, 1, 2, 3, 4, 5 of them, and others some special awards. Can we go ahead and present the individual gifts to each student, just to save time? Yeah. Dr. Mutawali, would you please come to the podium? Let's get each university one by one, universities one by one. Tennessee University has gift to each participating student. We can go ahead and present it first.
So these are little bags that you can fill up with. These are little bags courtesy of our college, and fill up with goodies from everybody in the exhibit hall. Thank you.
Thank you.
Thank you. Now, before I get the next team, let me just quickly explain. One of the reasons we were very excited to support this particular session, and as our sort of logo, which is an arrowhead, shows, we are trying to prepare our students for being 21st century Renaissance. So all of you trying to solve societal problems are Renaissance engineers in our view, and our mission is to produce those engineers who can are prepared not only to get jobs but also create jobs. They're going to be revolutionizing engineering to solve societal problems. So it was great to see all these examples of projects that are actually solving societal problems. And our arrowhead actually has some meanings behind it: 3 legs, innovation, research, and technology, and all coming together around technical leadership and global leadership. So you're the future leaders, and we look forward to you actually solving societal problems. So hope you'll see some material in our strategic plan as well in there. And actually, I'd like to make an announcement that everybody's a winner here, because any student here who decides to apply to Tennessee Tech for graduate program, I hereby wave a magic wand and waive your application. So if you participated in this session today, you can apply and not worry about the application. Thank you again.
Washington State, guys.
Is it?
all seniors.
Soon to be.
Sit
in my office.
Sort of. We're all in our junior year.
Well, you have to take a GRE.
Thank you.
Maybe if you actually come, we're refinding on GRE.
Can we have a group picture? Dr. Mutawala, can we have a group picture? Group picture.
Big picture.
You. Indiana students, are they busy? Indiana University? Indiana?
So, do TTU last in case we run out of bags. We'll give it to them back at the.
She's eating. My girl.
One, two. Pick high school. Except high school. One, two, three.
I thought we had global participation.
Texas A&M. Texas A&M. Gerald, Texas A&M.
From Missouri. I thought you were sponsoring. Thank you. How many bags should I be giving you? Because you kept on giving presentations.
One for now. One for now.
One
Later
for-
on,
one
more.
for now.
Okay.
Thank you.
One, two. Who else? Virginia Falls.
Great job with the presentation. There's no tokens of our appreciation.
Thanks a lot.
Come here and I hope that you will remember to
Sure.
and you might have heard that. So waiving the application if you want to apply to our graduate program.
Thanks a lot.
Thank you so much.
Is he really waiving the fee? I'm pretty sure he could.
He's actually a victim.
Looking for a box. You bring me something here?
Advertising over here, son.
A really long conversation. You know,
Hey, is there a Prairie View here? Prairie View High School, right?
No, we don't have that.
Prairie View University. Okay, they were on the list, but we didn't see them. Okay, you probably just mark it. Okay, we're back.
We can share any. Esther, get a share. Okay. was working as an athlete staff in Seattle. They sell like educational stuff and games and teaching resources for workbooks for kids. And most of them is my wife went to school with that's how I found out. Well, maybe. Oh, hey, that's how I look at it. I've seen it all. Of course not. Like no other. I mean, you. That's okay. You guys do. Oh, we're gonna just be by it. Yeah, well, we have
Yeah.
Oh, you're talking about the soul cat one. I was thinking.
No, to kind of How do you?
Welcome to the Focus on Exhibit Summertime Social, sponsored by Columbia Video Network Graduate Online Program. Be sure to stop by the diversity booth and leave your business card for the drawing doing tomorrow for the Focus on Exhibits lunch.
Yeah. I was in Texas Inland before. I was working with Dr. Chef.
Oh, yeah, yeah, yeah. I remember. Yes. Sorry.
Okay. So I did see the email for this one, but I don't have experience. We were actually got two great presentations. One about robotics, another one about this. But we don't know what kind of extent, what kind of extension that we need to go, how deep. Oh, sure. Yeah.
Like next year, we do it every week.
Sure. Now, the topic changes every year.
This year, environment, next year, legacy. Every single. So which school were you with?
I'm at Ocean State.
That's by JNP Finance.
Oh, yes. From Texas. Oh, what else? Mine. Weather contract.
Some kind of water. You too. Okay.
So do you have a team? Yeah.
Yeah, I have 2 teams.
2 teams. So,
now I have to go back to the door.
One side's kind of hard.
You got all kinds of cool kids that you don't see for us.
Good job on the question. Hey, I figured we're not thinking, for the winners, we're not thinking anything within the hashtag answers. We'll do more, we're done with the question. It's not Michelle. No, it's not. It's someone else. Did you read through that?
I saw that. That's a different story.
Oh, it is.
All right. Sorry. Probably they must go talk it out on their day.
Latest one. Ooh.
You would have told me that, I would have tried harder. I already had enough one surprise. How do you think it'll be?
I don't know. This is still working on always a hard.
Always. I didn't think it was that hard. I thought it was pretty obvious who was the winner. I mean, it's all different. Do you like SolidWorks better than Autodesk?
I don't care. They give us free versions, so we follow them.
Yes, I should.
They thought it was gas. I know
How do you want to document this?
Okay, so we have these for every participating team.
Cool,
Are
very
you
good.
ready?
Yeah, we're ready.
You announce it, so we
Cole, Wayne, and me, and him for the award. Let me
Now, one of the downsides is we all had scores for all over the place because the scoring that you have on the sheet. Well, we didn't add the scores up. I mean, we could give you scores if you like, but we don't have anything to document them on. So how do you do that? I mean, you want a sheet to give to them, or okay? So I can explain. We can explain. Here's why, and we can do third, second, first, and then the innovation. Right?
Cole, Wayne, myself, and Dr. Kuhn for the awards, and him and Dr. about you're the presenter.
Oh, I am. Okay, I guess that figured out. We were wondering who was going to do this. Now we know.
Microphone.
Okay, so third place is for
Each of us will present something.
Yeah. Oh, I'm on camera. All right, everyone. We have our announcement awards. First of all, before we get started, all of you have some complimentary gifts for participation. Besides being in Seattle and enjoying this place, which is awesome. And it's a shame we give these awards, like we give everybody awards, but we did do some scoring. And so we're going to start with third, second, and first place overall, and then we'll have the innovation. So as I announce you, how do we want to do this? Okay, our announce. What do we do?
Announce third one, and let's get started.
Okay, come on up and get it. So third place, Texas A&M, team number 7, for the food processing award. You want to take pictures? Very good. I wasn't even part of this morning. By the way, they just picked me up off the street in case you're curious. Thank you very much. Second place, these were all very close, by the way. Second place for universities was Washington State University.
Yeah.
Please come forward. Big team. Can I do a picture of this? You may try. I'm not sure how the field of view is. Good. Get in here.
Just scan.
Okay, got it.
Is that all the pictures?
He's getting his camera going through here. Take a picture back of his head. There you go.
And make sure you tweet number one.
You good?
I'm good. I got it.
All right, thank you.
Too late.
First place, again, I'll remind you that this is really tough to decide, is the University of Prince Edward Island with their charcoal.
Woo!
Please come forward. First place. First place overall. So we have the Innovation Award coming up last.
Good job, guys.
The University with the overall Innovation Award, most innovative idea, goes to Texas A&M, team number 7.
Yeah.
Third place.
She's racking them up.
Congratulations, come on. Very innovative. And due to some issues with how the presentations went and so on, we didn't choose to award a high school award. Now, one other thing on this, if you're curious about individual information, all of you had very good demos. Obviously, if you actually demoed the project with you, they gave you a few more points. And then on the poster presentation side, understanding what kind of information you had, how thorough you were in the documentation and drawings and so on, and also the data that you presented as part of your projects. That makes a difference as well. Oh, you can't hear me? That's a first. Okay, I'll go ahead and hand it back over to the organizer, Dr. Allen.
All right, so I would like to thank the judges. Can we all give the hands to all 3 judges? It's been a long time for them. And congratulations to all the teams. I know it's everyone you win. So we're happy it's going on every year. So after my email, I'll let you all come up again. So congratulations and have a safe trip home. See you
Thanks
next
all.
year.
Great time. Make a decision.
Signing off.
So it's over, Jason. Thank you. We'll do the make it session tomorrow.
Yeah, I'll be there.
I might arrange everybody 5 minutes to talk to. Do you think we will make it here? Where are we gonna make it?
I'm pretty sure it's here. I'm not 100%. You'd have to talk to.
Yeah, it says the same location. Well, I mean, on the schedule, it says the same thing.